You can hear me?
Yes, we can hear you.
Thank you. Uh, All right, I'm still going to be sideways. Boy, that's not coming in very good. I'll get the green shield behind me for the lecture. All right, you should be seeing my screen now. Today is January 16th, and we should be covering Lab 02 on aseptic transfers. Let me remind you, you do need to read the textbook through chapter 3 through the end of the section discussing compound light microscopy. You need to have that read before we begin Lab 3 next Tuesday and Lab 4 next Thursday. Any questions about any of that? Let me also remind you, you need to finish your plagiarism quiz by this Saturday. If you do not get 100% on the plagiarism quiz, you will get 0 points on the infectious disease project. Any question about any of that? All right, let's begin. Lab Module 2 is on aseptic transfers. The learning objectives for this lab are: 1, understand the purpose of using aseptic transfer techniques; 2, determine if aseptic transfer was used from the data that's provided; and then 3, be able to find the following terms: what is ubiquitous, what is aseptic transfer, what is inoculation, and what is a contaminant. Any question on any of that? There will be some videos in this lab. In our local environments, microorganisms are ubiquitous, meaning that they are essentially everywhere. This is a problem when working in a microbiology lab because we generally want to work with a pure culture. A pure culture is one that only has one species of microbe or bacteria in it. Louis Pasteur developed the technique of making an aseptic transfer to minimize the risk of culture contamination. Let me also mention that Louis Pasteur is the one who developed the first technique for obtaining a pure culture. His technique was difficult to do, and that is you did it in a liquid culture, and you did it by limiting dilution, and you'd make 10 replicas of each dilution. And if you ever had a dilution where only 1 out of 10 tubes got growth in it, Louis Pasteur correctly assumed that the 1 tube with growth would be most likely a pure culture, because 9 of the transfers did not give rise to anything in the tube. Contamination is the accidental inoculation of unwanted organisms into a pure culture. In this lab, we'll learn how to make aseptic transfers. We will not use Louis Pasteur's method for getting a pure culture. We'll use Dr. Koch's method. And Dr. Koch used a solid culture, and then you streak it out on the solid culture, obtaining an isolated colony. And then you take the cells from that one isolated colony, streak it out a second time on another plate to get a second isolated colony. And if you take cells from colonies that have gone through 2 colony isolation events, you will most likely come up with a pure culture. It's not 100% guaranteed, but it is over 95% guaranteed that the culture will be a pure culture. And that is good enough in microbiology. So during inoculation of a plate, never lay the test tube cap or the lid down on the surface. So pretend this is the surface. Hopefully you can see that. I can't see my picture here, so don't know if you can see this. Don't put the lid down on the surface. And don't put it down upside down either, because something microorganism could fall into the lid from below. Are you able to see what I'm trying to demonstrate? Anyone?
I can see it.
Okay, great. Thank you. What you need to do is hold on to the cap and the lid and then inoculate the tube. If there's bacteria on that loop or on that loop, we then have inoculated the media. So to minimize contamination when inoculating a media, if you have a tube, you should tilt the tube at an angle and then pretend this is a loop, bring the loop into the tube at an angle. That way, if something falls down from the air, it has limited surface. If you can see this, you can see it's got limited surface to come in. Most of the time, it'll fall down on top of the side of the tube. We don't care if it hits the side of the tube. And then when you're inoculating a plate, you is pretend this is a plate. You should not remove the lid all the way and then open it something like this, and then bring your loop inside and then inoculate it. And that way, if something falls down from the air, it only can come in at this limited space or this limited space right there. Most of the time, if something falls down from the air, it's going to hit the surface and won't come into the uh, plate and contaminate the plate. Any question about any of that? So that's how you inoculate in the lab. And I think that was actually in lab 01, where it was asking you what you can do to minimize airborne contamination. And that's something you can do and something you can do. And then the other thing you can do is you leave the plate or the tube uncovered when you're working on it for as little time as possible. And then you take the loop out as quickly as you can, and then you cover the plate as quickly as you can so that the uh, plate or the tube has minimal time for a bacteria to fall down from the air and then contaminate the tube or the plate. Any question about any of that? All right. In order to inoculate, transfer cells to new sterile media, we must make sure that we sterilize everything that can potentially contaminate the sterile media. Oh, and let me state that although this wasn't shown in the last lab, they did discuss it. So that's why it was asked in the last lab. Here are some of the tools we use for starting a new culture. We don't actually have a Bunsen burner in the lab. We do, but we don't use it. We use the Bacto incinerator, so we never use the Bunsen burners unless electricity is off. And obviously, we have enough light coming in the windows to light up the lab. So it'd work in the day, but not in the night. Um, and then we could turn on the Bunsen burners and students could still do the lab. And then you have sterile tubes with sterile media. And then we have a loop, and then you stick the loop in either the flame of the Bunsen burner or in the red hot rock of the Bacto incinerator to make the wire portion of the loop red hot. and then that'll sterilize it, and then you need to cool it, and then pick up the bacteria. I've got a blue sign here. Why is that? Am I talking to you guys? Can anyone hear me? Or did Zoom
Yes,
die?
I can hear
Okay.
you.
I've got a symbol saying something like, um, this is not working right. And I'm not sure there. It's actually working. It's the right color now. It was giving me the color before that Zoom had died. That's why I was concerned. Um, all right. Know the terms of this lab. What's aseptic transfer? What's a contaminant? What is inoculation? What does ubiquitous mean? What is a stock culture? This is something that already contains cells of one species that you want to use. That's a stock culture. In this lab, you're not physically going to be performing any of these activities because everything we do will be done online. But you will be watching videos of these activities, as well as we will give you results to the activity. And we expect that you will know and understand the material in these videos and in the pictures of the results that we give you. In procedure one, you're going to be transferring a sterile liquid using a glass pipette to transfer a sterile liquid into a liquid tube. So watch the following link demonstrating the proper aseptic transfer technique to use. So click that link there. And procedure one, you're going to transfer 1 milliliter of sterile water into a tube containing nutrient broth. When you use a glass pipette or you have a glass birette that is marked, you'll note that water will not go across the surface. What's the term? Flatly. It will form a meniscus like this. And that happens in plastic as well, although it's not as strong of a meniscus as it is with glass. And that's because the water is more highly attracted to the glass than it is to the water. And so it forms a meniscus like this. What you need to do when you're reading a meniscus is you read it from the bottom of the meniscus. You do not read it from the top of the meniscus. You don't read it in between the bottom and the top, meaning the average of the meniscus. You read it from the bottom, and that would be 1 milliliter. All right, there is the tube of media you're going to inoculate. You can note its color and whether it's turbid or not. Rough cultures are problematic because it's difficult to determine if contamination has occurred in the culture because all the cells mix together in the liquid broth. So you cannot see colonies in a liquid culture. Any question about any of that? In tube one, number one, we're going to inoculate. Well, we're not going to inoculate. We're going to put 1 ml of sterile water in the tube and then determine whether the tube has growth in it or not. It should not because it's sterile water we're adding. Just a minute here. I have to sneeze. May still sneeze, but we'll see. When you're working with a tube, remember it needs to be appropriately labeled. You get a piece of tape and you put your name on it, the tape, the date, the type of medium it is. The incubation temperature is optional, and you do have to say what it is you're growing. The inoculum, like in this case, well, actually, it's later in the case, not procedure one, but procedure three. We will be growing Serratia marcescens In this case, you just say sterile water was added. And then you come down to this table where you have the interpretation of the results. You will not be making these observations in a lab, but you will see a picture giving you the results for procedure 1 through 4, and you should be familiar with the popular possible outcomes given in this table and the conclusions. For procedure 1, if the nutrient broth is clear, no organisms are growing in the broth is the conclusion, and aseptic transfer was successful. If in procedure 1, on the other hand, the nutrient broth is turbid, where it's hazy or cloudy, then the conclusion is organisms are growing in the broth and aseptic transfer was unsuccessful. You then come down to this picture, and there's procedure 1, that tube there. You note it. And then you come down, you answer. I think in your case, it'll be labeled question 0. And describe the initial clarity of the nutrient broth prior to your inoculating it with the sterile water, or for procedure 2 with the paper disc. Was it clear or turbid? Write your answer there. And then do question 1, the result of procedure 1. Describe the clarity of the nutrient broth after inoculating with sterile water and overnight incubation at 35 degrees C. Was it clear or turbid? And then 1B, based on these results, what conclusion can be drawn? And you must use the wording of the table. Let me see if that's stated in here. Yep, see, that's question 0. And right there, I've got the wording in there. I need to add that to mine. Your conclusion must use the wording similar to the table above. If you do not have similar enough wording, your answer will be wrong because you have to discuss 2 things. And let me change this here. There we go. And then 1C lists 3 sources of error with aseptic transfer technique that could explain why the nutrient broth showed growth of microbes in the tube. So each of the asterisks has to have an answer. Any question of that? Let's see if I can pull that up just a little. Oh, that's still not far enough. There we go. All right, any questions about procedure 1 and the questions you have to answer for this lab? If not, let's go on to procedure 2. In procedure 2, you're going to transfer a sterile paper disc using sterile or clean forceps. So you're going to transfer a sterile paper disc into nutrient broth using not sterile forceps, but clean forceps. It's close to sterile. And what you do is you get your forceps and you stick them in alcohol. And then you bring the alcohol covered forceps to the Bechtel incinerator and light the alcohol. And then go and pick up the sterile forceps. I mean, the paper disc, and then add it to your tube of media. Following that procedure there. And then you get the tube to grow in the incubator overnight for about 24 hours. and then take a look at the tube. And for procedure 2, if the nutrient broth is clear using this table, you need to give a conclusion. Are organisms growing in, no organisms are growing in the broth because the nutrient broth is clear. And then aseptic transfer was successful. So when you're discussing the conclusion, you must discuss two things: whether there's growth in the tube and whether aseptic transfer was successful. And then if nutrient broth is turbid, hazy, or cloudy, the conclusion is organisms are growing in the broth and aseptic transfer was unsuccessful. Any question about any of that? And this is the picture for procedure 2. And there you can actually see the paper disc in the bottom of that tube. And then come down to question 2. The result of procedure 2, describe the clarity of the nutrient broth after inoculating with the sterile paper disc and overnight incubation at 35 degrees Celsius. Was it clear or turbid? And then 2B, based on these results, what conclusion can be drawn? Once again, you must use wording similar to the table above. Any question about that? All right. For procedure 3, we're going to be transferring Serratia marcescens to a broth culture. There's some notes about, you have a little video for transferring to cells into a culture, and you can watch this little video. You only need to watch this video to 4 minutes and 23 seconds. The bacterium being used in the video is E. coli. The bacteria that we're going to use is not E. coli. It will be Serratia marcescens. And so the color of the bacteria in the video will be different than the color of the bacteria you will be inoculating your tube with. E. coli is white or off-white, and you're going to be inoculating with Serratia marcescens, which is reddish or pinkish in color. You should note that an error is made when the instructor puts the loop into the stock culture of E. coli. You can hear that error someplace between 3 minutes and 5 seconds into the video and 3 minutes and 20 seconds into the video. Do you know what the error is? You can hear sizzling when he puts the loop into E. coli. And you should try and figure out what the instructor did that was an error when he put the tube into the video. And this is just for your own information. You don't need to, you can do not need to write about it, but you can if you wish. You won't get any credit for it, but there's an error the instructor makes, and you can hear the sizzling when he puts the loop into E. coli. So in procedure 3, you will be using aseptic technique to transfer Serratia marcescens into a sterile broth tube. And Serratia marcescens, when it grows in a liquid culture, will appear pink. Now remember, broth culture is a problem because it's difficult to determine if contamination has occurred because all the cells will mix together. So you cannot see colonies like a colony that's not pink. All the cells will look together. And if there's major contamination, you might be able to notice it. But if there's minor contamination, the media will look pink from the Serratia marcescens, and you will not see the color of the minor contaminant because the cells are too small in number to determine, well, to change the color. We'll just word it that way. And once again, for the conclusions and the results, use this table. For procedure 3, if the nutrient broth is clear, no organisms are growing in the broth, and aseptic transfer was unsuccessful. Why do we say if the nutrient broth is clear for procedure 3 that no organisms are growing in the broth, and yet for procedure 1, if the nutrient broth is clear, we're saying that no organisms are growing in the broth? Why are we changing it? Wait a minute, we're not changing it. Not that part. That part is correct. It's right here. The aseptic transfer was unsuccessful for procedure 3. But yet, if the nutrient broth is clear in procedure 1, we're saying aseptic transfer was successful. So why are we changing it? You'll have to think about that because I'm not going to tell you. All right, you guys
Is
can. Huh?
is it because certain organisms like to grow in certain cultures and some don't?
No, this is a general purpose media, so the majority of the organisms we use in the lab can grow in uh, a general purpose media. So if I had I don't know, selective media, you could maybe argue that, but this is a general purpose media. So it's not because some organisms can grow in it and others cannot, but that's a good guess. Anyone else have a reason why we say the nutrient broth in procedure 1 is, if it's clear, aseptic transfer was successful, but for procedure 3, if the nutrient broth is clear, we're saying aseptic transfer was unsuccessful? Well, what are
Is
we
it
doing in procedure
uh,
1 and what are we doing in procedure 3?
well, it said it's a colored pigmented bacterium, so is that the reason it should be colored?
It should be colored, but the what I'm trying to get at is in procedure 3, you're directly inoculating the tube with cells. And yes, they are colored. So there should be growth in the tube because you put the cells into it. In procedure 1, you're inoculating the tube with sterile water. So we expect no organisms to grow in the broth if aseptic transfer was successful. Okay,
That makes
so
sense.
that's why there's a change. All right. There's the picture for procedure 3, and you can notice it's pink. And then come down to question 3. For the results of procedure 3, describe the clarity of the nutrient broth after inoculating with Serratia marcescens in overnight incubation at 30 degrees C. Was the tube clear or the tube turbid? And then 3B, based on these results, what conclusion can be drawn? Once again, you must use a wording that's similar to the wording in the table above. And how do you know, procedure 3C, you have to answer this one too. How do you know whether you have transferred the correct microbe, Serratia marcescens? All right, any question about that? If not, let's go on to procedure 4. In procedure 4, you're going to use aseptic technique to transfer Serratia marcescens to a sterile agar slant. Serratia marcescens, when it grows in a solid media, should have red pigmentation to it. And when you're growing growth on a slant, you inoculate it by um, picking up your cells, pretend this is a loop on a sterilized loop, cool the loop before you pick up the cells, and then you put it into your stock culture, pick up the cells, and then take the loop and you inoculate the surface of the slant with an S-like motion, and then your growth should grow on the streak. And if ever you see a region which is not pink, like this region right here, If it's not pink, you know that region right there is a contaminant because Serratia marcescens should appear pink. So determining contamination is much easier when you have growth on a solid media because you can actually see the colony. The contaminant will not look pink in this case, and so it'll be a different color than you're expecting, and so you can see the contamination. So especially when you're growing Serratia marcescens, which will be red, it's much easier to see contaminant. In a liquid culture, all the cells will mix together, and if you had minor contamination in this tube, let me see if I can show you the picture. If there's minor contamination in the tube will still appear pink, so you cannot see minor contamination. You would have to see major contamination before the color would not be pink or some other color. All right, any question about procedure 4? And then use this table for interpreting the results and making your conclusion about procedure 4. If the slant does not show confluent or colony growth, then no organisms are growing on the slant and aseptic transfer was unsuccessful. If the slant shows confluent or colony growth, organisms are growing on the slant and aseptic transfer was successful. So here we have the slant, and there's so much growth growing that you don't even see the streak, that the entire region where we streaked has growth. And then there's some liquid in the tube, and so we're getting the bacteria growing around this way as well. You don't need to know this, but Serratia marcescens can swim, and if there's a drop of water here, Serratia marcescens will get into it and then spread there. So that's the results of procedure 4. Come down and answer the questions for 4. For the result of procedure 4, is there bacterial growth on the slant? Just need to answer yes or no. How do you know there's growth on the slant? So discuss that. And then for procedure 4C, does it appear to be the bacterium you inoculated or a contaminant? And you must explain why. Any question about the questions or the procedure for lab 02? If not, remember, well, you actually can only answer questions in the worksheet, which is right here, lab module 2. And I will be here until 4 o'clock, or the last student logs out, to help you with any questions. Remember, in this lab, unlike the previous week's lab, you will get 2 attempts to answer the questions on this lab. On lab 00 and lab 01, you only would be able to turn in the lab 1 time. In this lab, if you don't get 100% the first time, you can turn it in again about by next Saturday. That's assuming that I get all of them graded by Tuesday. But if I get them all graded by Tuesday, then I will make the due date next Saturday, meaning a week from this Saturday, for the second turning in of the lab, and the lab will be worth full credit on both this Saturday if you get 100%, and then if next Saturday, if you didn't get 100% this Saturday, you can turn it in again for possible credit of 100% by the next Saturday. And let me remind you, you should be answering a question in the student discussions by January 18th, so you still have 2 more days to answer the question. And that is, do you want the labs to be turned in 1 time, or do you want the lab to be graded 2 times? Okay? So answer that question, and I will go with whatever the majority of the class decides. Last term, I had everybody turning it in 2 times, and some students complained. So I've changed it, and this term, the majority of the class will determine what we do with turning in the labs. Any question about any of that? All right. So go ahead and get started on the lab. I will be here to answer any questions until 4 o'clock or the last student logs out.
I have a question for the labs. So, will it be entered in the gradebook as 2 separate grades, or will it just change the original? Will there just be one grade for the lab, even
There'll
though
just be one grade for the lab. If you turn it in a second time, you will get it regraded, and the second grade will be your grade. I've only once had a
Okay.
student who the grade actually went down uh, because she changed an answer that was correct to something that was wrong, and then she answered the wrong question with another wrong question. So only once in all the years I've been doing this, where students were allowed to turn in the labs twice, has a student ever had a decrease in their grade. So usually, in all other cases, the grade has improved on the second time. Okay.
Do you make corrections and then we
On the
redo?
first grading, I will tell you which questions are wrong. I won't tell you what the answer is,
Okay.
but on the second grading, I will tell you what the answer is. And if you want the uh, answer, let's say you get 100% on the lab and you got one question wrong, because on the first grading of the lab, if you miss one, I will give you one error. And if you want the answer to that question, you can just email me and I will send you the answer to the question. Because usually, if you get 100%, I do not grade those labs again. So if you want the answer, just ask and I'll send it to you. But most students will actually get 100%, and there will be nothing for me to make a correction. But if there's something wrong and you got 100%, then just ask for the question. But if you got it wrong, I will tell you the first time what the question was wrong, and then the second time, I will give you the correct answer if you got it wrong the second time. All right. Any
Okay.
questions? All right. Go ahead and get started on the lab.
Are when we get tested, when we get tested on chapter 10, is it just going to be up to pages 272, or do you want us to do all of chapter 10's reading?
No, you only need to do the page numbers that were assigned in the reading. Those are the
Okay.
only pages of chapter 10 we're going to discuss.
Okay. Okay, thank you.
All right. So we just was asked a question about whether we should use the wording verbatim from the table when we're talking about the results and the conclusion. You may. You can just quote it. You don't need to put it in quotes and say where you got it from, because obviously I knew you took it from the table. But you may use the exact same wording, or you can just use your own wording that's similar. Either way.
Okay, thank you.